Yep, that's me. It's 2022, and I'm in the middle of my computer science degree, waking up to find hundreds of thousands of layoffs happening across the technology sector. No internship, no industry experience, no impressive resume project. Just me, my degree, and the slow realization that I may very well never get a job related to it. Wow, there's some real panic right there. So I get this idea. Maybe I could build a video game. Maybe it could make me money. Maybe it could become a portfolio project. Maybe it would make my resume stand out. 4 years later, I have a Steam page, a playable demo, and a lot more knowledge about game development. But I'm getting a bit ahead of myself here. Let's go back to the beginning. Now, I wasn't completely starting from zero. Back in high school, I had made a few extremely basic games using something called processing. So, it being what I knew, I decided I was going to use that to make my video game. For anyone familiar with game development, you can probably already see the problem, or you're just laughing out loud. But please stay with me here. That phase didn't last very long, don't worry. Processing is a great tool for learning programming and making small visual projects, but it's not exactly what you would normally want to use if you're building a commercial video game. Still, it was basically the only tool I knew, and I gave it a go, and it did not go very far. I started researching other options, even though I did not yet completely understand the difference between a game engine and a framework. I vaguely remembered having tried Unity back in elementary school. I think I managed to put a cube into a scene, move it around, and then promptly gave up. Of course, this was back in elementary school, so I didn't really have a lot of resources around me back then. Still, I also had Unreal Engine, but my computer was nowhere near powerful enough to be running that, so that wasn't going to cut it either. Eventually, I came across Godot. I honestly don't remember why I chose it. It has been over 4 years, and I wasn't exactly planning on making a YouTube video detailing this journey. I can say it was free, lightweight, and actually ran well on my computer, which was probably enough to convince me, but again, I don't exactly remember. So I downloaded Godot 3 and began learning how to make scenes, nodes, scripts, and everything else. It's surprisingly intuitive if you have a computer science background. Following basically every piece of beginner game development advice that I could find online, I started in 2D. Most people say that 2D is simpler. 3D introduces modeling, lighting, cameras, and more complex physics. Honestly, that advice makes a lot of sense, so away I went. And here's my first attempt at making my 2D Moin game. As you can see, it was not going very well. The visuals were, to say the least, very rough. The movement had strange bugs, and I kept running into problems with Godot's old tile map system. Honestly, most of those problems were probably user error, and I could have fixed it if I had spent more time on it, I think. But there was a more important issue here, and that was I was just not having a lot of fun making it. I would become distracted very easily. Instead of fixing the Moin game, I started an underwater resource extraction game. I experimented with procedural train generation. Spoiler alert, procedural train generation is something that I keep coming back to in my game development journey. I watched experienced developers build amazing systems, and then I discovered that the general understanding and the actual implementation are extremely far apart in their difficulty. The project would break, I would return to my Moin game, make a little progress, and then disappear into another experiment. Eventually, though, I decided that I needed to ignore the advice and move into 3D. Now, moving from a simple 2D game into a 3D game was the exact opposite of making the project easier. But once I started experimenting in 3D, something changed. For the first time, I was not only making a game because I thought it might look good on my resume, I was actually having fun developing it. I play almost exclusively 3D games, so it makes sense that I would enjoy making those instead of the more 2D oriented adventure I was on. That did not mean I suddenly started making sensible decisions. One of my first experiment was an attempt at creating a large, procedurally generated open world using cubes. I was essentially placing a huge number of blocks in the world and hoping they would somehow become an open world terrain system. Unsurprisingly, the performance was not great, and some of the more experienced developers out there are probably laughing at me again, but don't worry. I read some posts online warning beginners not to make an open 3D world game for their first project, and I accepted that I might be slightly in over my head. So I scaled things back and returned to my Moin game, only this time I rebuilt it in 3D. I did not know how to create proper models yet, so the moor was made from simple shapes and the world was made mostly of blocks, and the sky was about as basic as possible. It was extremely rough, but this was the first version that felt like a game I would actually want to make and play. Moving into 3D introduced plenty of new problems, but it also made game development fun for me. And in a project where nobody was forcing me to continue or I had deadlines that I needed to meet, that mattered more than choosing the easiest path possible. Unfortunately, enjoying the project and consistently working on it were two entirely different things. I was still completing my computer science degree, and most of my time went towards classes, assignments, and exams. This was also during the period when life was beginning to return to normal after the worst years of COVID. Development happened in short bursts. I would add a feature, leave the game untouched then for a while school took back over, and then return to it later. I wanted it to become a serious portfolio project eventually, but eventually is a very convenient deadline. Then Godot 4 was released. This could probably take a video on its own, but Godot 4, to say the least, is not a normal update. The engine's 3D rendering had been completely overhauled. It offered better lighting, more modern features, and a much stronger foundation for the kind of game I wanted to make. And naturally, I became fixated on one particular feature: sky shaders. Did my basic mowing game desperately need advanced sky shaders? Probably not. But I can say now that considering how long the project took, it was probably the right choice to make back then. The migration itself was not smooth at all. Scripts broke, systems had changed, features I depended on worked differently or had been replaced altogether. I tried repairing the project, but the deeper I went, it felt like I was fixing something that had been built around an entirely different engine. Eventually, I decided to start over. Looking back, I'm still not sure that was the best choice. Perhaps I could have finished a smaller version of my game in Godot 3 and then used Godot 4 for my next project. But rebuilding also gave me the chance to reorganize the project, rewrite systems, and improve the quality of the code. That helped me avoid carrying over every beginner mistake I had been making into my new version. The visual difference also appeared fairly quickly. I moved beyond simple cubes, began using actual grass meshes, improved the lighting, and added a proper day and night cycle to my game. For a while, everything seemed to be going surprisingly well. Then I ran into the biggest technical problem I had faced so far. You see, what I had been using up until now was something called GridMap 3D, which allows me to place 3D objects onto a grid in a similar way to placing tiles onto a 2D game. It worked well enough when the entire lawn was made up of simple cubes, but with the Godot 4 and me making the switch to more complicated grass meshes, the collision stopped behaving properly. The game sometimes failed to detect which grass the mower was touching, which is a fairly serious problem when the main mechanic of the game is cutting grass. I tried fixing GridMap, then I tried working around it, then I tried replacing it. One solution was to place every piece of grass into the world individually. This technically worked until I added tens of thousands of them into the game, which performance completely tanked. I also experimented with Godot's low-level rendering systems, but I could not get those working properly either. For a while I was stuck. Then I found a Reddit post explaining what GridMap 3D was actually doing behind the scenes. I won't bore you with all the technical details, but in short, it was treating every grass tile as a separate object, and then combining them into groups for a larger chunk. This allowed the computer to render whole sections of the lawn together instead of processing each piece individually. GridMap, of course, can do much more than that, but I did not need all the other features. I just needed a large grid of grass that could be cut. So I built a simplified version of it for my own game. My system combined sections of lawn into larger meshes and rendered each section as one chunk. And somehow, it actually worked. For the first time, I could create a large lawn with detailed grass while maintaining good performance, even on my old GTX 1060 that I was using at the time. The system was not perfect, it depended on certain values lining up, and there was plenty of ways that I could improve it, but it solved the problem for now. And more importantly, it was my solution. I had not downloaded a finished plugin or copied some tutorial. I had learned how the underlying system worked, reduced it to the parts my game needed, and created my own implementation. This was before generative AI tools became widely available, and so this was mostly me, the Godot documentation, and increasingly obscure Reddit posts. Up to this point, I still felt like a beginner stumbling through the engine and hoping things would work. Solving this showed me that I could understand difficult technical problems and build my own solution. For the first time, I had created a system that I was genuinely proud of. Solving a technical problem is one thing, but in this story and in indie game development itself, the real problem is motivation. If you're a good enough programmer, a technical problem can usually be solved eventually, or worked around. Motivation, on the other hand, is a daily struggle. There were still long stretches where I barely touched the project. Sometimes school took over, sometimes I lost momentum, and at a few points, I more or less gave up on it. Then graduation began getting closer, the job market was not improving, and the original reason I started working on this game came back into focus. I still needed something substantial that I could show people. So I returned to the project, but I hadn't actually solved the fundamental problem that I was facing on motivation. I still very easily got distracted. I experimented with procedural terrain, continuously generating worlds, oceans and underwater scenes, compute shaders, and other systems that never fully became complete games. But they were not useless. They taught me about chunking, culling, graphics programming, memory management, rendering processes, and optimizations to improve performance. These experiments were one of the reasons the game took so long, that's true, but they were also one of the reasons I became a much better developer. Every time I returned, I brought something new back with me. Eventually, though, I realized that just learning new techniques and building cool and interesting systems was not enough. If I kept waiting for motivation and jumping to whatever seemed exciting, the game would remain a collection of unfinished ideas. So more recently, I changed how I approached the project. I began working more consistently, deciding which features actually mattered, and returning to unfinished systems instead of immediately chasing the next experiment. This also meant that accepting that not every part of game development is exciting. Sometimes the work is just adding a major visual feature, or fixing a small bug, reorganizing code, or cleaning up a menu, finishing a system that has been half complete for a long time. That change in approach has produced some of the project's biggest progress so far. So where are we now after 4 years? Well, you saw what it looked like in the early 2D days, then when I started 3D. Now this is what it looks like now as of making this video. The game has detailed grass, foliage, weather, sound, lighting, and a much stronger sense of atmosphere. Basic more mechanics are complete. Of course, some polishing can be done, but that is for later in the project. The next major focus is on the interface, the main menu, the job system, where players can accept mowing contracts, earn money, and gradually build their business. Eventually, I will have to tackle the enormous task of building a saving and loading system. That's going to be a thing. Some versions of these systems already exist, but many of them were unfinished or built when I had much less experience. The game is still not complete, and I'm not even going to pretend that it's close to being complete, but it has moved far beyond the broken prototype phase that I made with cubes, and it's a playable demo. It has a Steam page, and it has become something that other people can actually download, play, and follow. So after 4 years, was it worth it? Did the game suddenly make me rich? No. Did it instantly solve the job search problem? Also no. Did it become something for my portfolio that I can put on a resume? Yes it did. It also gave me practical experience with things like rendering, shaders, procedural generation, optimization, debugging, user interfaces, save systems, and probably most important of all, how to maintain a large code base. More importantly, it taught me how to approach problems without obvious answers. When something broke, I had to research it, test different ideas, and understand why they failed, and eventually try to find something that would work. It also taught me that completing a large project requires a lot more than short bursts of motivation. It requires consistency, deciding what matters, returning to unfinished work, and continuing even when the task is not currently very exciting. I started this project because I was afraid I would graduate with nothing meaningful to show for my degree. 4 years later, the game is still not finished. But I'm no longer the person who had nothing to show. Every failure, distraction, and restart helped me turn from someone who barely knew how to move a cube around into someone capable of building a real game. And I still have a long ways to go. I plan on making more videos covering the development process, including a deeper technical dive on some of the systems in my game. If you want to follow along on that journey, consider subscribing. Also, if you want, you can wishlist the game on Steam right now. The link is in the description, as well as the link for the playable demo that you can try for yourself. If there's a particular part of the development process you want me to explain, or a technical explanation that you want for one of the systems I mentioned, leave a comment below. It may become a future video. Thank you for watching and supporting the project. The game has come much further than I ever imagined in 2022, and it still has a long way to go. I hope you will stick around to see where it ends up.